All right, I wanted to do this tutorial on this 3 by 3 by 4. So 3 by 3 by 4. I want to do a tutorial on how to solve one of these because I thought that this would be a good one to start with for somebody just learning cuboid strategies, which is not your basic 3 by 3 or 4 by 4 or 5 by 5. You still need to know some of the basics for solving a 3 by 3 in order to understand how to do this one. So what I'm going to do is I'm actually going to split this into two videos. The first video, I'm actually just going to go through some of the algorithms that you're going to need in order to solve most cuboids and some of the basic cuboid algorithm strategies. And then the second video, I'm actually going to go through an actual solve using all those strategies with this 3 by 3 by 4. Alright, so let's go ahead and get it going. If you already know the strategies or if you've already watched this video, then go ahead and go on to the second video, which will be the actual solve. Alright, so one of the things that you're going to need to know is the way this one moves is similar to a 3 by 3 with the exception of the right side here or the left side here. There are certain times where you cannot shift this thing 90 degrees. I mean, I can turn it 90 degrees, but then I can't do anything else with it. I'm stuck because, as you can see, I've got 4 pieces here and only 3 pieces here. There's no way for those to line up and move it 90 degrees. So in this case, my right side, my left side, and by the way, I'm keeping the yellow and the white as my top and bottom in this case. So the right side, left side, front and back can only move in 180 degree turns in order to go ahead and move them again. Okay, the top and the bottom can move as many ways as we want to, 180 or 90 degree turns, and then we can go ahead and move those again. Okay, so some of the algorithms that we're going to need, and what I want to do is I want to walk through the algorithms with you guys and explain to you what's actually happening. So I'm going to try and do this in a relatively decent order so that it's going to make sense when you actually try and go to solve one of these yourself. One of the first ones that we're going to need is what I call the corner drop. And what it does is it flips these two corners right here. So it'll take this corner and drop it to here, and it'll take this corner and move it up to here. So this is one of the basic strategies that you're going to need. Again, I do require that you're going to already know something about the algorithms and how the standard 3 by 3, 4 by 4, and so on work, because I'm going to be using the notation for that when I talk about the algorithms here. So the corner drop, moving these two corners, is going to be right 180 degrees because that's all you can do. Upper, right 180 degrees. Upper inverted, right 180 degrees. And what we've done is I have taken the orange, green, white from down here, was the orange, green, white, shifted it up here, and then I've taken what was the yellow, blue, and green, and now it's down here. And I've dropped the corners. I've switched the corners. It does mess up some of the other stuff, but as you can see, the main thing it does is it creates this parity. And there's going to be several moves that are going to create this particular parity. One of those is this corner drop, and what you can see is what happened is this entire set of bars right here, this row in the center, these two rows in the center, have actually flipped. The blue orange actually belongs over here, whereas the green orange actually belongs over here. So what you can see is these two rows have rotated. So if I rotated 180 degrees, I'll put these rows back, but then of course my corners and everything else are out of place. So these two rows have been flipped. And what that is, it's because of the number of times that I had to turn. This right side was an odd number of times, so it created that parity right here. And that'll be a parity that we're going to go through towards the end of this thing, because every once in a while this is going to get to a point where you just can't get rid of it at the end, and then we're going to have to fix that parity. Alright, so that is the corner drop. So I'm going to go ahead and fix my corners right now by doing the same thing. And again, it was right 180 degrees, upper, right 180 degrees, upper inverted, right 180 degrees. And as you can see, now we're fixed again. And it also fixed the parity, but that's again because I turned this an odd number of times. I turned the right side 3 times, so it fixed the parity back to where it was. Okay, and when I do the corner drop, I always hold the corners in my my right side here facing me. You can also do it from the left side if you're ambidextrous and can do your left hand as well. It's just the exact opposite, but I'm going to be doing everything from the right side perspective here. Okay, so another one that we're going to need after we're done being able to do this corner drop is we're going to need to be able to swap 2 corners on the top. So on this top layer, if I wanted to swap the yellow, green, orange and the blue, yellow, orange, if I wanted to swap these 2 corners, I can do that. And this is one of the longer algorithms that you're going to need, and it's got a couple of extra steps in it. But once you do it enough times, and believe me, if you do enough cuboids, you will, it's not really that difficult to do. And the good thing about this one is if you're really paying attention to what's happening up here, when you get close to the end, you can kind of see what you're supposed to do anyway. So these 2 corners, if I want to swap them, and the good thing is it will not create parity here, and you'll see why. If I want to swap them, it is right 180 degrees, upper, right 180 degrees, upper inverted, right 180 degrees, upper inverted, lower. That's key because you don't want to mess this guy up on the bottom. Right 180 degrees, upper inverted, right 180 degrees. As you can kind of see now, this white bar is fixed, so I want to bring it back so it's upper, and then right 180 degrees. So I'm going to go ahead and fix the bottom because I moved the bottom that one time at that particular step. It's still in the same place. I haven't messed anything up there, but what I have done is I have swapped these corners. The orange, blue, yellow from here is now in the front, and the green, yellow, orange is now in the back. So I have swapped these 2 corners. It did not create any kind of parity here. It did not flip these, and that's because the number of turns here on the right side was even, so it kept this in exactly the right orientation. It did mess up this center, and I'm sorry, this edge and this edge on the top. So those 2 things have been swapped, and we're actually going to learn how to do an edge swap when they've got edges that are wrong. So I'm going to go ahead and do the algorithm one more time, and I'm going to put these corners back, which will actually fix these edges. So again, it's going to be right 180 degrees, upper, right 180 degrees, upper inverted, right 180 degrees, upper inverted, and lower, right 180 degrees, upper inverted, right 180 degrees, upper, right 180 degrees, and as you can see now my top is fixed. I swapped these corners back and it actually fixed the opposite edges. And then on the bottom, because I did the one bottom turn that I needed to, I can just now turn that back and we're all fixed again. Okay, really I think that there's just 3 more algorithms that we're going to cover. The next one is going to be, there's going to be a time when you're going to have to swap 2 adjacent edges. And to swap 2 adjacent edges, this is one, again, this is another long algorithm, but if you're good with numbers, this isn't really going to be that difficult to do because I've kind of come up with a pattern in my head that I say, and I'll, explain the pattern after I do it once, because after I do it once, it's going to be messed up, and then I'll do it again. I'll just kind of tell you what the pattern is. It's a long one, but if you can kind of think of the pattern, it's really not that difficult. So it's going to be, if I want to swap the yellow-orange and the yellow-green, so it's to my front and to my right, it's going to be right 180 degrees, upper, right 180 degrees, upper, right 180 degrees, upper twice, right 180 degrees, upper twice, right 180 degrees, upper, right 180 degrees, upper inverted, right 180 degrees. So now you can see that the yellow-orange that was here is now here, and the yellow-green is now over here. So I swapped these two particular edge pieces right here, the two adjacent edges, again, to my front and to my right. And again, because of the odd number of turns, you can see that I've created the parity. I flipped these two bars completely over. So if it was like this, then they would be right. So I flipped these two bars right here in the middle. So this one does create that parity, that bar parity there. Alright, so now to fix this, I'm going to do exactly the same thing, because now I want to swap these back, and when I do, this parity here will be fixed, because again, it's going to be an odd number of turns of the right side. So the way I think about it, because it's a lot of different turns, is a pattern. So I know I'm always turning the right side 180 degrees in between every turn, but then it's going to be the top, which is going to be a turn of 1, 1, 2, 2, 1, and then the only one that's backwards is the last one. After it's 1, 1, 2, 2, 1, then I go back. But again, by that time, you should probably be able to see that by going back on the right-hand side, you're going to fix the top. So let me show you what I mean. So it's going to be right, 1, right, 1, right, 2, right, 2, right, 1, and then the last one, right. I know I have to bring the white and the orange back over here to match, so it's back, and then fix it with doing the right side. Okay, so that swaps two edges. One of the other ones, and this is the probably the easiest one to do, is if I want to swap two opposite edges. So I'm going to swap these two opposite edges. I'm going to put the green yellow over here where the blue yellow is. So I'm going to swap these two opposite edges, and again, it's going to be an odd number of turns of the right side, so it's going to create this parity right here. Okay, so it's going to be, this is the easiest one. Right, upper twice. Right, upper twice. Right, upper twice. And again, what you can see is that I've now taken the blue-yellow from this side and put it here, and the yellow-green is now on this side right here. So I've swapped these opposite edges, and again, it was an odd number of turns of the right side, so I have flipped this side right here completely over, and as you can see, if I turned it this way, now everything up here is messed up, but this is now completely flipped. So again, I'm going to do this one more time, and it's going to be fixed. So this is the easiest and shortest one. It's right, upper twice, right, upper twice, right, upper twice. And there we go, we're fixed again. So invariably what's going to happen eventually is you're going to end up with a parity where this thing right here is all that's left that's flipped. You've got all the pieces up here, all the pieces down here, everything else, but these two bars right here are flipped. When it comes to some additional cuboids, such as this 4x4x6 or the 3x4x5 or any of these other cuboids where you have more than just 4 layers here, as you can kind of see on this one, you could get just this middle row, which is flipped. In this case, it's actually usually going to be two pieces, these two pieces here, and these two pieces here, and it's really going to, it's exactly the same algorithm, so that's why I said it's a good strategy to know this one. And what it does is it takes these two bars, if they're flipped, and it turns them back the right way. There's also going to be one where you could take it, like on this one right here, you could take one bar that's flipped and flip it over the right way, or multiple bars at the same time. It just depends on which cuboid you're working with, and you'll have to go through that on your own. But in this case, what I'm going to do is I'm going to go ahead and quickly put it into the part where this bar, these two bars are flipped, and then I'll go through the algorithm with you guys. So just bear with me. Oops. Okay, so this is what you'll end up with. And I'll go through that relatively slowly with you guys. So again, I've got everything else fixed, but now I have to flip these two bars. And this can happen sometimes during the middle or during the end of a solve. In this case, it usually only happens that you might have to fix this at the end. And as we go through an actual solve in the next video, I'll explain why that is as well. Okay, so if we want to fix these two bars, and again, this is a strategy that you're going to use for any of the rest of these, even the shape-shifting ones. This one doesn't shape-shift, but this one does, this one does. there are a couple of others that are out there. Actually, there's several others that shapeshift for cuboids. Once you get them back into the basic cuboid shape, this is a pretty important algorithm to be able to do. Okay, so it's kind of long and you're going to have to memorize it, but it does happen frequently. And if you do this one, boy, does it happen really frequently, and you have to use it several times to fix it. So what it is you're going to take and split these two pieces in half. So you're going to keep the bars in front of you, so it needs to be to your front. And we're going to take and we're going to split these two pieces in half by doing both uppers 180 degrees. Then we're going to do the right side 180 degrees and the front 180 degrees. Then what we're going to do is, if you kind of look at this side, this is going to hopefully make some sense. I'm going to take the both uppers and go 180 degrees. And then I'm going to take just the top upper and go 180 degrees. And what you can see is I've got these two greens now matched up, and I want to get those greens out of there. So now it's going to be front 180 degrees. And when I do that, now these are all good, these are all good. The only thing that's not good is this white piece on top has to go down here. So it's now right 180 degrees, and now all I have to do is fix my tops, and I've got the bar. So again, let me go through that. I'm going to go through this one really quickly 2 more times just to make sure. I'm going to give you the algorithm to, basically we're going to undo it and put the parity back in, and then we're going to go ahead and solve the parity. So the algorithm for this is upper twice, right, front, upper twice, the top upper twice, front, right, upper twice. And I've created my parity. So now to go ahead and fix the parity, once again, the algorithm is both uppers twice, right, front. Both uppers, top upper twice, front, right, and then both uppers. And I'll put all this in the descriptions below just so that you guys have the parities, and I'll explain which ones are which. But really, those are the basic parities that you're going to need to be able to go ahead and, I'm sorry, not the parities, the algorithms that you're going to need to be able to go ahead and solve this 3x3x4 cuboid. So in the next video, we will go through an entire solve, and hopefully we'll end up with one of every one of these things. And you can see exactly how it is that you're going to solve one of these.